Welcome to Intelligence Gateway.
Understanding database security. Database security is the practice of protecting databases and the data stored within them from unauthorized access, data breaches, data corruption, and other security threats. Database security is a critical aspect of overall data management and ensures the confidentiality, integrity, and availability of data in a database. Here are some key concepts related to database security. 1. Authentication. Authentication is the process of verifying the identity of users who are accessing a database. It involves verifying usernames and passwords, or other credentials, to ensure that only authorized users are granted access to the database. Strong authentication mechanisms, such as multi-factor authentication, MFA, can provide an additional layer of security. 2. Authorization. Authorization is the process of granting or restricting access permissions to users or user groups based on their roles, privileges, and permissions. It ensures that users can only perform actions in the database that they are authorized to do, and prevents unauthorized access or actions. Fine-grained authorization controls can be implemented to limit access to specific data or operations. 3. Encryption. Encryption is the process of converting data into a secure, unreadable format to protect it from unauthorized access or interception. Data encryption can be implemented at various levels, such as at rest, data stored in the database, in transit, data transmitted between the database and clients, and in application code or stored procedures. Encryption can prevent unauthorized access to data even if the database is compromised. 4. Auditing and monitoring. Auditing and monitoring involve tracking and recording activities and events in the database, such as logins, data modifications, and access attempts, for security analysis and detection of potential security breaches. Database activity logs, event notifications, and security information and event management (SIEM) systems can be used for auditing and monitoring purposes. 5. Patching and updates. Keeping databases and associated software up to date with the latest patches and updates is essential for protecting against known security vulnerabilities. Regularly applying patches and updates provided by the database vendors helps to address security vulnerabilities and minimize the risk of exploitation. 6. Backup and recovery. Regularly backing up databases and storing the backup securely offsite is an important security practice. Backups provide a means to restore the database to a previous state in case of data loss or security breaches. Proper backup and recovery procedures, including encryption of backups, should be followed to ensure data integrity and availability. 7. Secure coding practices. Writing secure code in database applications and stored procedures can prevent vulnerabilities, such as SQL injection, that can be exploited by attackers to gain unauthorized access to the database. Following secure coding practices, such as parameterized queries, input validation, and avoiding dynamic SQL, can mitigate the risk of such attacks. 8. Least privilege principle. Following the principle of least privilege involves granting users only the minimum permissions necessary to perform their tasks in the database. This minimizes the risk of unauthorized actions and data exposure in case of user accounts being compromised. 9. Physical security. Physical security measures, such as securing the database servers in locked rooms, using access controls, monitoring and logging physical access, and securing backups, are also important for protecting databases from unauthorized physical access and tampering. 10. Employee awareness and training. Educating employees about database security best practices, including safe handling of credentials, password security, and data access controls, can help to create a security-aware culture and minimize the risk of insider threats. Database security is an ongoing process that requires regular monitoring, updates, and proactive measures to protect against evolving security threats. By implementing appropriate security measures and best practices, organizations can safeguard their databases and the sensitive data stored within them from unauthorized access and data breaches. Protecting data using access control and encryption. Protecting data using access control and encryption are important security measures that can help safeguard data stored in a database. Here's an overview of how access control and encryption can be used to protect data. 1. Access control. Access control involves granting or restricting permissions to users or user groups to access and perform operations on the data in a database. Access control mechanisms ensure that only authorized users are able to access and manipulate data in accordance with their roles, privileges, and permissions. Access control can be implemented at various levels, including database level, table level, and even column level, depending on the database management system, DBMS, being used. Database-level access control. This involves controlling access to the entire database. Typically, only authorized users or user groups are granted permissions to log in and access the database. This can be achieved through authentication and authorization mechanisms, such as usernames and passwords, roles, and privileges. Table-level and column-level access control. This involves controlling access to specific tables or columns within a database. For example, different users or user groups may have different levels of permissions on different tables or columns based on their roles or responsibilities. This allows for fine-grained access control, where users only have access to the data they need to perform their tasks. 2. Encryption. Encryption is the process of converting data into a secure, unreadable format to protect it from unauthorized access or interception. Data can be encrypted at various levels, such as at rest, data stored in the database, in transit, data transmitted between the database and clients, and in application code or stored procedures. Encryption at rest. This involves encrypting data stored in the database to protect it from unauthorized access in case the database is compromised. Database management systems often provide features for encrypting data at rest, which typically involve encrypting the database files or specific data elements within the database. Encryption in transit. This involves encrypting data as it is transmitted between the database and clients to protect it from interception or eavesdropping. This can be achieved using secure communication protocols, such as SSL/TLS, which encrypt data as it is transmitted over the network. Application-level encryption. This involves encrypting data within the application code or stored procedures before it is stored in the database. This can provide an additional layer of security, particularly for sensitive data, as it ensures that the data is encrypted before it is stored in the database, and decrypted when retrieved. Implementing proper access control and encryption measures can help prevent unauthorized access to data, reduce the risk of data breaches, and protect sensitive information stored in a database. It is important to follow industry best practices and recommendations for access control and encryption, and regularly review and update these measures to ensure ongoing data protection.
Thanks for watching. For more information, like, comment, and subscribe our channel.